Hello my dear students, myself Manjunath Bharatpach. Today we are going to see one of the important derivation for second PUC chemistry in the chemical kinetics chapter, that is to derive an equation for K for the first order reaction. We should derive an equation for the K value. It is one of the important derivation for 3-mark question in the main board examination. Let us see. Consider the first order reaction. If they are asking you that equation for K, let us consider the first order reaction. Consider the first order reaction. How it is there? Let the reaction, we are going to write it as generally as reactant giving rise to product. So we consider a one first order reaction or giving rise to product. According to let us assume let constant R naught be the initial concentration. Let R naught be the initial concentration and concentration of R be the present concentration. Be the present concentration. So we are going to assume that R naught be the initial concentration. So before starting any reaction, that is the concentration is R naught. So at some time after reaction started, the concentration be R. Now, according to the from rate definition, rate is equal to, we are going to write it as the reactant concentration is decreases with respect to time, d by dt of concentration of R. So according to the from small change in the concentration of reactant, that is rate, be the equation 1. From according to rate law, rate is equal to K into R to the power, if the order is 1, let it power is 1. So be the equation 2. From equation 1 and 2, both are the rate, so I can equate the RHS. So minus d by dt of R, which is equal to K into R to the power 1. So let us rearrange the equation. We can take R 1 by concentration of R and we can send that dt to that side. D into concentration of R is equal to K into dt along with the minus sign. So I hope you are going to understand. So R power 1, so 1 we can write, or we can also neglect. 1 by R is equal to D into concentration of R, that minus sign is shifting to RHS, K into dt. So let us integrate this equation. Let us integrate, integration symbol, 1 by concentration of R into concentration of dr, which is equal to minus K into dt. See, integration does not affect for constant values, that's why we are going to write it outside the integration symbol. So 1 by concentration of R is ln R, which is equal to minus K. So integration of dt is T plus I. What is that I? Where I is the integration constant. Where I is the integration constant. To find out the value of I, we have to consider when time t is equal to 0, when time t is equal to 0, the concentration of R become R naught. The concentration of R is equal to concentration of R naught. So when the time is 0 means before starting a reaction, the concentration of reactant will be the initial concentration. That we are going to write it mathematically as concentration of R is equal to concentration of R naught. Let us substitute in the above equation. Ln concentration of R naught, which is equal to minus K into 0 plus I. So anything multiplied by 0 is 0. So I is equal to ln R naught. So let us substitute I value in the equation. In the place of I, we have to replace by ln R naught. So just a minute, I am going to rub this side part. The above equation becomes ln R, which is equal to minus Kt plus, in the place of I am going to replace by ln R naught. So now we will rearrange, taking the ln term to one side, Kt to another side. So minus Kt become plus Kt, which is equal to ln R naught minus ln concentration of R, which we can apply the logarithmic equation. Ln concentration of R naught by concentration of R, which is equal to K into T. I want the value of K, then 1 by T into ln concentration of R naught by concentration of R. So we convert the ln into base 10, we have to multiply by 2.303. The K value is 2.303 by T into log of concentration R naught by concentration of R. So this is the final equation for the first order reaction for K value. This is the one of the important derivation with respect to our board examination concern. 3 mark important derivation. K is equal to 2.303 by T into log of concentration of R naught by concentration of R. So this is the final expression. Thank you for watching this.